How's it going, everybody? Mr. Dickin here. In this video, we are going to be talking about how we can write the equation of a quadratic function using the zeros. And remember, when I say zeros, that's just another phrase or term for the x-intercepts. So any point that has a y value of 0 is considered a 0, or a root, or an x-intercept, or a solution. So let us begin. First thing we need to do is kind of clarify the fact that there's a direct relationship between having a factor and knowing the x-intercept that pairs up with it. So here it's generalized, where if you have a factor of x minus some number, well, you're going to have an x-intercept, or a 0, at said number. So what we're asked to do here is write a quadratic equation in standard form. So standard form, in case we forgot, and it's okay if you did, is ax squared plus bx plus c. Now they're telling us that we have zeros at 3 and negative 5. Well, if I apply the logic right here, I can then say if there's a 0 at 3, then there has to be a factor of x minus 3 that would produce that. Similarly, if there's an x-intercept, or a 0, at negative 5, then I have to see a factor of x plus 5. Remember, the values of your zeros, it's always going to be the opposite of what you see in the factor. So positives and negatives, you'll always be using the opposites there. So right now what I have is a function written in factored form. I guess if I really wanted to make it a function, I'd have to throw a little f of x there. There you go. But this thing clearly said, hey, we want standard form, don't we? Well, no big. All I have to do is just do some distribution. So we will FOIL this thing out, or distribute. I know it's going to start off with an x squared and end with a negative 15. And then I just have to figure out what's going on in the middle. So I'd have a negative 3x and a positive 5x. Negative 3, positive 5, it's going to be a positive 2x. There we go. All right. So now we have some practice problems. We're going to write the quadratic equation again in standard form, given zeros. So just like before, we're going to start off and write these things in factored form. And then once it's in factored form, we'll throw it into standard form. All right, so number one, if I have two x-intercepts at negative 6 and positive 2, then my factors would have to be x plus 6 and x minus 2. Now from here, I just distribute that out. We would get x squared plus 4x minus 12. Number two, 4 and 0. Well, I'd have to have an x minus 4. And then the second factor, you could do a plus or a minus 0. It doesn't really matter, right? Because it's 0. 0 doesn't have a sign. So right now, the way I have it written is still holding true to what we've been doing. I will give you the little heads up of anytime you have a plain old 0, that's just going to be a plain old x. So if I were to write this out, I'd actually write it like that, x times x minus 4. These two are saying the exact same thing. I just kind of flip-flopped the order of the factors, and I used a plain old x instead of an x plus 0 or x minus 0. And since it's one single term, I don't need parentheses. I could put parentheses there around the x, but you don't need to. But I digress. When we distribute, we would get x squared minus 4x. Now 3 and 4 are going to get a little dicey. A little bit dicey. If I follow the pattern I've been doing, we'd have x minus 1/2 and then x plus 5. Now some of you might be on edge right now because we're dealing with fractions. And typically fractions don't really make an appearance in factored form. So anytime you see a fraction, here's what you need to do. We need to take this term And to get rid of the fraction, what we're essentially going to do is multiply the denominator of your fraction over here as the coefficient. Okay? Now I'll explain why that works. So when we do that, we're going to get 2x minus 1 is what we're going to use instead. Now if I were to set each of those factors equal to 0, oops, wrong tool. If I had x minus 1/2 and I set that equal to 0, I could solve that x equals 1/2, easy peasy. If I were to set 2x minus 1 equal to 0, well, I'd just add 1 to the other side. 2x equals 1, and then divided by 2, x still equals 1/2. So we're still going to get the same result, regardless of how it's formatted. All I did is just made it so we're not dealing with fractions by essentially multiplying this entire equation by 2, right? 2 times x is 2x, 2 times 1/2 is 1, 2 times 0, well, anything times 0 is just 0. So I kind of simplified this out by just multiplying that denominator over. Okay, so now let me shrink this stuff down. Now that we have that out of the way, this is what my factors should look like. And we just need to do some distribution. So we're going to have 2x squared, and then we're going to have a 10x, right, 2x times 5, 10x and a negative 1x, so that's going to be 9x, and then negative 5 at the end. All right, number 4 is going to be awfully similar. So number 4, we're going to have x minus 3/2. Not a huge fan of that. Let's use what we've learned. 2x minus 3. And again, all I did is took that denominator and essentially threw it in front over there. And then x minus 2. We do some distribution here. We'll get 2x squared. And then we have 2x times negative 2, so negative 4x. And then a negative 3x, that would be a negative 7x, plus 6 at the end. Cool. All right, onward we go. Quadratic function has negative 6 as its only 0, so it's got one and only one x-intercept. Is this possible? If so, explain. All right, so I'm gonna try to visualize this here. So here's my coordinates, right? And then we have some sort of a quadratic. So a quadratic is just a parabola. Right now I've got a scenario where there are two x-intercepts. If I were to move this parabola up a little bit, well, now it doesn't hit the x-axis at all, so there are no x-intercepts. They're telling me, though, that it has exactly one x-intercept, so one and only. Well, what that means is that the vertex of this would have to be the one and only x-intercept, so on the x-axis. They're telling me that happens at negative 6, so it would be right about there. Okay? So now if I were to write this equation, I know it's going to have an x plus 6, but then what do I do for the other factor, right? Because I need to have two factors here. By definition of quadratic, it needs to have an x squared. So I need to have another x something, something, something over here. Well, why not just repeat this x plus 6? And I'll write it out again. So now I'd get the same result as my x-intercept for both factors. Another simpler way to write this would be x plus 6 quantity squared. Now, if we were to do this in standard form, we would just have to FOIL that thing out. You'd get x squared plus 12x plus 36. Now, one thing I should mention that I haven't really brought up yet is that when we're doing these values and we're writing all these equations out, all I need to have is just the x-intercepts to create the factors, right? That's all I need, and that's all we've been using this entire time. I didn't make note of any sort of a value that could be in front of the whole thing, right? There could be maybe a negative sign in front of the whole thing. Maybe it was stretched by a factor of 3. I don't know. But the thing with these is it doesn't matter. If I were to throw a coefficient in front of this entire factored thing and distribute that in at the end, so maybe I multiply this entire equation by, say, -1 or -17, that's not going to change the x-intercepts. So when we're doing these, primarily focus just on the factors. If you want to throw an a value other than 1, I'm not going to stop you, but by no means do you have to. Onward we go. All right. Given that 4 is a 0 of this equation, what is the value of b? All right, so they're telling us that 4 is a 0, so that means I know there's a point 4, 0 on this graph. And that essentially gives me an x and y value. So what I can do from here is I can actually set up an equation. Instead of y equals, I'm saying my y value is 0, so 0 is getting plugged in for y. And I can throw 4 in for x right there. So this would be 3 times 4 squared plus a mystery b value times 4 minus 8. And we could just simplify this thing out. All right, so 0 equals, let's see, 4 squared is 16, so 3 times 16, 48, plus 4b minus 8. I've got some like terms here, so that would be a 40, but if I move it over, it's -40 on the other side. So I'm getting b is -10. That's one way that we could solve this. Now another way that this could be solved, and there's no necessarily like correct or incorrect way to do this, so let me scooch this stuff down, is if I know that we have an x-intercept, that means I also know that there's a factor of x minus 4. Well, if I know one of my factors, I can kind of reverse engineer what this term would have to be. In order to get a 3x squared at the front, this would have to be a 3x. In order to get a -8 at the end, this would have to be a 2. And then from here, if I just kind of FOIL this thing out, I could figure out that middle term. Because that middle term is just going to be the result of, let's see, this would be 2x, right? X times 2, and then a -12x. That's going to be -10x. And we said our b value is supposed to be -10. So there's a few ways that we could have done that one. All right. Now if we're given a graph, it's going to be the same process. The only change now is instead of them telling us the x-intercepts, we have to visually find the x-intercepts. Where does it hit the x-axis? Now it's asking us name some things that are the same about all three of these quadratic functions. Well, they all have the exact same x-intercepts. They also all have the same axis of symmetry. And that kind of makes sense because the axis of symmetry is always going to be smack dab in between your x-intercepts because things have to be symmetric. So if they have the same x-intercepts, they have to have the same essential midline right there. What's different about all of these? Well, some of them have been stretched or compressed by different factors. You'll notice the red and blue ones, they're both opening upward, but the red one is much more vertically stretched out. And the green one's been flipped, so the green one's got a negative coefficient in front of the whole thing. So when we write these equations, we're really going to rely on the zeros. However, we also have to make sure that we're paying attention to, is this an upward or a downward opening parabola? And did it get stretched or not? So let's see. Here it's asking us, what are the factors of the quadratic function? And is the a value positive or negative? So this is kind of nice. It's not actually asking us for the a value. It just wants to know positive or negative. So we can actually just look at these, right? If it's a smile, it's positive. If it's a frown, it's negative. So this one's going to have a positive a value, negative a value, positive a value. Number 4 down here, negative a value. I did not mean to write that with a highlighter, but whatever. All right, so let's get our factors out, shall we? This one I've got -2 and +4. So it's at -2 and +4. So I'd have the factors of x plus 2 and x minus 4. And since we said it was positive, I just leave this coefficient up front positive. I could put a +7 if I wanted to, if that fit the stretch factor here. But it's just asking, is our a value positive or negative? Let's see, number 2. I've got x-intercepts at -3 and at 0. And remember, anytime you have a 0, that's just a plain old x. And then we'd have x plus 3 as our other factor. You could have those flip-flopped in order. The order doesn't matter. It's just typical. If you see a plain old x, you just throw that in front. And this one is negative, so I need to throw a negative in front of the whole thing. That negative sign is not going to change the x-intercepts. It's just going to change the behavior of the graph, opening up versus down. Number 3. Right here we have an x-intercept at -1, and that's the only time that happens. So as a factor, that would be x plus 1. But by definition of a quadratic function, I need to have 2 factors, right, to develop an x squared. So I'll just throw a squared there. This one was positive, so no coefficient needed there, or no negative coefficient needed there. And last one, number 4. We get -1, so that'd be x plus 1 as a factor, and +2, so that'd be x minus 2 as a factor. And we said this graph was negative, so I'll just pop a negative sign out front. And that'll do it. All right, guys, that's it. Hope this made sense. If not, you know the drill. Feel free to reach out, ask a question, let me know. And as always, good luck, have fun, be safe, roll tide.